The idea of our paper is to take an incomplete facade as input and to automatically generate a plausible completion. Given an incomplete input facade, we use box abstractions to represent the elements of the facade. The proposed solution is to break the problem into two components, a statistical model to evaluate layouts and a planning algorithm to generate candidate layouts. For our statistical model, we define a set of attributes that determine grid structures that we consider as good grid structures. We learn the distributions over the attributes from a dataset of example facades. Then we use them to score the quality of input grid structures. We consider scoring functions defined by the properties of one single grid, by relationships between two grids, as well as global properties of the facade. Then we combine them into one unified statistical model using a factor graph. In the second part, we propose an approach that mainly generates reasonable completion candidates using a planning algorithm. We cast the problem as an optimization problem that finds a completion that maximizes the layout score. Our algorithm searches a state space from a starting state by applying the actions successively. Our method is to design a probabilistic policy that can be configured by a parameter vector lambda. To keep the algorithm simple, we only consider actions that add one facade element to the current layout. A policy has a set of parameters and it generates an action based on the following steps. First, we select a seed element. Second, we decide the extension direction. Third, we compute the extension spacing. And finally, fourth, we decide the label of the new element. We formulate the setting of the parameters as a policy optimization problem. For each facade, we compute the optimal parameters using a genetic algorithm. Here is an example of candidate generation. We generate 10,000 structure candidates during a policy optimization for each incomplete facade. We sort them by their score and either select the best one or use multiple solutions of different ranks to obtain different suggestions of how to complete a given layout. Here we show 4 completion results. Now, as an application, we propose a modeling scenario using our completion method.